Hello class, so let's look at solving this problem here. We're trying to find the acceleration of the mass A, the tension in the string, and at the end we're going to plug in the numbers using the coefficient 0.2 for coefficient of friction, which only applies on mass 1 in this case, since mass 2 is hanging. So let's draw this. To start, we have the table here, and hanging off the table we have one mass, which is mass 2. Mass 1 is sitting on the table, and of course there's a force of friction since it's sliding, and we're not assuming that this is a frictionless surface. For this system of equations, let's draw the free body diagrams for each of the masses. So for mass 1 we have the Fg and Fn normal force that are acting on it, since it's sitting on a surface, a flat horizontal surface in this case. The objects are going to be moving. We're going to assume here that they're moving towards a heavier mass, which let's just call that T, and opposite to that we have the force of friction, since it is sitting on a non-frictionless surface. So let's quickly write Fg is going to be mg, Fn is going to be opposite that. At force of friction is going to be, in this case, mu mg, m1g. Let's specify here because we have two different masses. For the second mass, we have just the tension in the rope that is slowing it down from free falling, and the force of gravity, which is m2g, for the two masses that act on this object. For these systems, the easiest thing to do is instead of writing negative like accelerations as negative and positive, just think of the forces opposing each other, because we're going to have an x direction and a y direction for this system. For the x direction, it's the same. So this is the acceleration, for example, for the system is going to be in the x format, and be the y direction for mass 2 for mass. So mass 2 is going to go up, down in this case, and mass 1 is going to go to the right. So x direction for m1, y direction for m2. So always think of them as negative forces instead of just always using gravity. For acceleration of gravity is always negative 9.8, for example. So when we are looking at the system as a whole, the net force, there's, again, we're assuming there's a net force here. And that is going to be, we can assume that there is a net force because it doesn't say that there isn't. It doesn't say that there's actually the objects are at rest or they're moving in a constant velocity. So if they don't, we're going to assume there's a net force, and that net force is the mass of both objects, m1 plus m2, multiplied by the same acceleration, because they're tied together, so they get this acceleration. And that net force is going to be the thing that is causing it to move is going to be the force of gravity of the second object, Fg2, and the opposite to that is going to be the force of friction of the first object. So we're going to say minus the force of friction of the first object. Okay, so this minus is because it's going in the opposite direction. Okay, so always think about it that way. It just makes life a lot easier when we are solving more complicated like systems of equations. So in this case here we have so let's put the equations that we wrote. So we rewrite this as m1 plus m2 times A of the system, that equals mg m2g minus times m1 and g. So if we want to solve for A system, that's going to be m2 minus
system, which applies on mass 1 or mass 2. Mass 1 in the positive x direction, mass 2 it's going to be in the negative y direction. If you want to just think about it, so these are vectors, so you do need to describe the direction of the mass or of the force or the acceleration. Just use words or negative if you choose to identify what is negative, what is positive. So that's the acceleration of the system, or for mass 1. The tension in the string. So when we look at the tension is what is, you can look at mass 1 or mass 2. I'm just going to pick mass 1. If you're looking at mass 1, the F net in the x direction, so F net in the x direction here is mass of object